Next, we will see what is Hamilton path and what is Hamilton circuit. So here, Hamilton path is a simple path in a graph that passes every vertex exactly once. So what is the difference between Hamilton path and Euler path? In Euler path, we have to traverse every edges at most once, and here for Hamilton path, we have to visit at every vertex exactly once or at most one. Similarly, for Hamilton circuit, or most of the time it is called Hamilton cycle. So Hamilton cycle is a Hamilton path that is a cycle. So that means you started from a vertex V1 by traversing every vertex of a graph, you go back to the same vertex v1. Okay, so suppose there are many vertices in between, so there are many vertices in here, so you started from vertex v1 and by visiting every vertex you go back to the original vertex. Now here's the thing, in Hamilton path and Hamilton cycle you can visit any edges as many as you want, but you cannot visit any vertex more than one time. So let's see an example. Suppose there are three graphs is given in here. So we will try to find out which one has Hamilton cycle or path. So this is very simple. For G1, we can see that we can go A to B, B to C, C to D, D to E, and D to E to A. So we can clearly see that we actually visited every vertex at most once. We do not need to visit every edges. So there is a Hamilton circuit on G1. Okay. Now what about G2? So we can try to see how many vertex we can visit. We can start from A. We can go A to B. We can go B to C. We can also go C to D, so we can see we have visited all vertex, but if we wanted to go back to A, so we need to visit vertex B again, so that is not possible in Hamilton path. So that is why we can say that G2 is not circuit because we cannot go back to our original vertex, but there is a Hamilton path. Now if we look at G3, so let's try to check. So we go A to B, B to G, G to E, E to F, but we cannot visit C or D instead of again visiting E. So therefore we can say that G3 is neither Hamilton path nor circuit. Okay, so this is neither. Now again, if we look at graph G and H, so here this is also very straightforward. We can visit all the vertices, but we cannot go back to our original vertex. So we can say that both G and H, they has a Hamilton path. Both has Hamilton path. Like Euler path and Euler circuit, whether there is any theorem that will help us to determine whether a graph has Hamilton path or circuit, there is no precise theorem that will precisely identify that a graph has Hamilton path or cycle, but sometimes people use the following two theorems, but it is not always helpful. But let's see what are those theorem. The first one states that if G is a simple graph with n number of vertices and n is greater than or is equal to 3, such that the degree of every vertex in G is at least n over 2, then that graph has Hamilton circuit. There is another theorem sometimes that is also applied to determine Hamilton circuit. So what is that? It states that if G is a simple graph with n number of vertices, definitely n is greater than or is equal to 3, such that the degree of U and V is greater than or is equal to the total number of vertices. What is U and V? Here U and V, they are pair of non-adjacent vertices. If this is the case, so then we can say G has a Hamilton circuit. Again, Sometimes this theorem is helpful, but it is not always true that by applying these two theorems, we will always able to identify the graph has Hamilton path or circuit.